Hello and welcome back to my channel. In this tutorial I'm going to explain Shi-Tomasi color detection example with OpenCV in Python. Shi-Tomasi color detection, also known as a goodFeaturesToTrack algorithm, is a method used in computer vision to identify key points or corners in an image. These corners are characterized by distinctive features that can be tracked from one image frame to another, making them valuable for various tasks like object tracking, image stitching, and motion analysis. In this blog post, we'll delve into Shi-Tomasi color detection and its application with OpenCV. This tutorial covered the concept of Shi-Tomasi color detection, Shi-Tomasi color detection with OpenCV, and the conclusion. Let's get started. Shi-Tomasi color detection identifies important image points by analyzing intensity variations. Key features, like corners, are often characterized by significant intensity changes. It evaluates whether a pixel qualifies as a corner by examining the eigenvalues of the structured tensor, a 2x2 matrix summarizing intensity gradients. Shi-Tomasi uniquely uses the minimum eigenvalue to classify corners. Unlike the Harris corner detection, if this minimum eigenvalue exceeds a present threshold, the pixel is considered a corner. Corners are further ranked based on the cornerness score, with weaker ones discarded. A minimum distance parameter prevents close corner selection, ensuring a balanced distribution of key points in the image. In OpenCV, we can use a goodFeaturesToTrack function to perform Shi-Tomasi corner detection. Here is a brief explanation of how it works. We provide a grayscale image to detect corners. Max corner defines maximum number of corners to detect. It will return the strongest corners up to this number. Quality level between 0 and 1 that represents the minimal accepted quality of corners. Higher values result in fewer corners. And others are minimum distance, the equivalent distance between detected corners, and block size, the size of neighborhood considered for corner detection. And use Harris detector is a Boolean flag indicating whether to use a Harris corner detection method instead of Shi-Tomasi. The function returns a list of coordinates x and y representing the detected corners. Now let's explore the example below that demonstrates the implementation of Shi-Tomasi corners using OpenCV. In this example, we'll load the input image file, convert to grayscale, and keep one copy of image to display the result. We define Shi-Tomasi corner detection parameters, then detect corners by using goodFeaturesToTrack function. We convert corners to integrate and draw cycles at detected corners locations. Finally, we display detected corners on image. Here is the source code. First, we load the required libraries for this source code. We use OpenCV, NumPy, and Matplotlib libraries. Then we load the grayscale image. Then we define the parameters. Then detect corners using Shi-Tomasi. Then convert corners to integers, then draw cycles to detected corners location. Finally, we'll visualize the output result to color image. Here is the output. Here we detected the corners using Shi-Tomasi corner detection method. In this tutorial, we briefly explored the concepts of Shi-Tomasi corner detection and learned how to implement it with OpenCV. Shi-Tomasi corner detection identifies significant image features by analyzing the eigenvalue of structure tensor. It does so with a criterion that considers only the minimum eigenvalue and introduces parameters for quality control and minimum distance to fine-tune the corner detection processes. That's it for this tutorial. I'll put the source code right below this video. Please subscribe my channel and hit a like button if you like this video. Thank you for watching and see you next time.